Arduino for Beginners, Episode 16, Interrupts. So in the last episode, we took a look at how to connect a Hall effect sensor to Arduino. And we are going to be using that in this episode. So if you haven't seen that one, go ahead and check out episode 15 on how to connect this up. But we're going to be doing is using the Hall effect sensor. And we're going to be using interrupts to count how many times a magnetic field has passed in front of the Hall effect sensor. So, all right, let me bring the serial monitor up. All right, it should be up there now. And if I pass the magnetic field, you can see it counted 1. Now I put it there again. It counted 2, but you notice it does not continue counting. But if I remove the field and then place it in front again, it counts again. So the reason we're using interrupts is so that it only counts once for every time a magnetic field comes within proximity of the Hall effect sensor. That way, we're not just holding it there and it would just continue counting after whatever delay we put in the sketch. By using interrupts, we're detecting either if it's falling or rising. And we'll get to that when we get to the sketch. As you can see, and it will read pretty quick. I mean, you can use this to make an RPM counter. It's several thousand RPMs a minute, and it will work. All right, I think that's enough of the demonstration. Like I said, if you haven't watched the previous episode on how to hook this up, check that out. It's real short. Just a quick demonstration on how to hook this up. And then we used this LED, which we're not using now, just to show that when a magnetic field came in proximity, it turned the LED on. All right, well, let's just go over to the sketch. There's nothing really else to look at here, since you should already have this hooked up before you got to this episode. So, all right, I'm going to bring up the sketch on the computer, so I'll catch you there in just a moment. All right, I got the Arduino IDE opened up here. And, all right, as you can see, it's not a very long, complicated sketch. That's all there is to it. So what we have here is first is we need 2 integers. We're calling them old and new. And what we are using these for is for the counter, because we only want to have a serial print every time it's added 1. Instead of just having it serial print, with a delay, just keep printing the same number over and over again. What we're going to do is it's only going to print serial print if the number has gotten higher. So we're using an old and a new to keep track, and we'll get more into that in just a moment down here. So then in the void setup, we're doing attach interrupt, and we're using 0, and that will be on pin 2, and we're calling it Hall because that's what we are having the Hall effect sensor connected to. Now, beans, this kind of works like an NPN transistor. There will be voltage to the pin, and when the Hall effect sensor detects a magnetic field, it opens up and brings it down to ground. So therefore, we want to detect if it's falling. Then what we're doing is the pin mode, and that's pin 2. The Hall is on, the Hall effect. We're doing that in input, and we're the pull-ups. So we got the pull-up resistors. That way there is voltage to that pin, so when we do the reading, actually when it detects that it goes low, it's falling, because you need voltage on the pin. If you had it as an output, it wouldn't work. So just do the pin 2, input pull-up. That way there's voltage supplied to the pin, and when the Hall effect sensor detects a magnetic field, it will close and allow the current to flow through, which will call the interrupt because it'll detect that it's falling. Now, in the void loop, we just have if the new, which is our counter values, if the new value is greater than the old value, we're doing a serial print, and we're just printing the new value. and then we're making the old value equal to the new. That way it doesn't just keep printing. But for the interrupt, what we have is we have another void now. Now all we have in this is if a magnetic field is present and comes in proximity of the Hall effect sensor, it calls the void Hall, the interrupt, and it just goes and makes new plus plus, which means it adds 1 to whatever the value of it currently was, now increases by 1. And then that's what this if statement here is for. If the new value is greater than old, then it serial prints it and it makes the old new. I hope that makes sense to you. If not, look at it, play with it a little bit. You should be able to figure this out. It's not that complicated. It's when we get into doing the RPM, the tachometer, it's there's going to be a lot more complicated stuff we have to do with the interrupts, but interrupts are fun. There's lots of things you can do with them because they don't have to have any, if you got delays and stuff in your sketch, when the interrupt happens, it's instant. It stops wherever you are in the sketch. It stops instantly and calls that interrupt. So no matter where it is in the void loop, when this detects a magnetic field in front of that Hall effect sensor, it instantly goes to the void Hall. And you can have, on the Uno, you can have 2 interrupts. You can have 0 and 1. The Mega, I'm trying to remember offhand, I think it was something like 6 on there. And then there is some other way, there was something, you got to have a library for it, but there is a way to add more. If I remember right, that's something I haven't really played with, so. All right, well, I hope this made sense to you. I know we did kind of go through it a little quick, but I just wanted to cover the Hall effect sensor in these last 2, and also the interrupts, and then, because the next one we're going to cover the LCD screens, start having fun with them, and what we're going to do is once again, we're going to expand on this. Instead of serial printing or a serial monitor, for the Arduino, we're going to use an LCD screen to print our value to, our counter. All right, I think we can just wrap this up then. So, all right, next episode will be episode 17, and that will be the LCD screen. So, hope to see you there.